1b is about functions. You most likely did function stuff back in Algebra 2. But in an Algebra 3 or college algebra kind of course, function and function notation becomes very important because of the fact we're trying to get you ready for a calculus class. So I got to make sure that that you understand functions and function notation. So that's kind of where we're going to start. A lot of chapter 1 is going to be about functions. So first, let's talk about function notation for a minute. The way that I think of functions is like an input-output machine. So I think of there's some rule, and if I stick in that input, the rule will do what it does, and then it'll give me an output. It's an input-output machine, okay? So let's think of our rule is it's an oven set at 350 degrees. If I input chocolate chip cookie dough, I'm going to output chocolate chip cookies. If I input sugar cookie dough, I'm going to get sugar cookies. So it depends upon our input what our output is, but the rule of the oven is it's going to cook the thing that's inside, okay? So for a function, let's say we have a function as simple as it's going to square its input. It doesn't matter if I put in a 7, still going to square it. It doesn't matter if I put in some strange symbol, it's going to square it. So the rule of the function, just don't overthink it. I find my smart students, they overthink the process. I am inputting that thing, and I am getting an output. You can also think about it like an ordered pair. What is your input? What is your output? Okay, so that's how we get the x, y. Now in function notation, that's also f of x, if it's that's the most common, f, or g of x or h of x or whatever. But the input-output rule, because a function takes one type of input, one type of cookie dough at a time, and it does its thing, and it takes and pops out the cookies, you need to think about it is that input is going to exactly one output. That's what makes a function unique, that it has an input and a strictly one output sort of quality about it. So the output is your y or f of x. Please start thinking of those things. F of x is really just a y, and that will help you as you go through this process, okay? Do we have any questions about this initial kind of relationship or how this works? Okay, so that's how function notation kind of works itself. We'll see a little better that way. Okay, so now let's take a look at an actual function. So we've got this g of x function, and it's just a quadratic. Remember, the highest power to be in 2. And then we're going to take, and we are going to input an increasing level of difficulty stuff, okay? So the first thing I want to input is 6. So every place that our x is sitting, I am going to replace it with a 6. And I am just searching for the output. So this is really just going to be 6 squared plus 8 times 6 minus 24. Now, mathematically speaking, we have to follow order of operations. It does not matter how high up you get in mathematics. Order of operations is defined as it is, whether you're in calculus or Algebra 1. So we're going to do the power followed by the multiplication, and then we have now addition and subtraction only, which you can do from left to right. So that gives us 60. So technically, if we were to look at this graph, we should see an ordered pair of 660 on the graph. And we'll look at the graph here in a second. But that technically is the point 660. I input 6, I get out 60, okay? So it's a good idea to start thinking about it that way. We are going to represent functions a little differently than you would have in an Algebra 2 class. Again, this is more of a college algebra sort of pre-calc class. And so we have to start getting ready for what an Algebra 2 class would need. And so that representation as a point is helpful, okay? Now, when we input something like a variable in step B, we do have a little more algebraic things we have to worry about. We're still going to square it. We're still going to multiply it by 8. But since it's negative, it's a really good idea to take and put it in parentheses. Otherwise, you're going to mess up the negatives and stuff. It's common that you would mess that up, okay? So I would make sure, especially when plugging in a quantity with more than one term, like we're going to see in C, or a quantity that's negative, use parentheses, okay? So when you do that, when you square a negative, it becomes a positive. 4 squared is 16, x squared is x squared. Here we got negative 32x minus 24. Now those are all unlike terms. One has a square on it, one does not, and one doesn't even have an x. So leaving it like that, and especially in that descending order for your powers, is a good rule of thumb to kind of check your work and to organize your work. Okay? Do we have any questions on A or B before we jump in and do C? Anybody have any questions about A or B? Good? Does that make sense? Okay. Now, C becomes the most difficult because of the fact that we've got two terms. So it's not difficult when you first input it. It's just making sure that you follow the rules of algebra as you simplify it. So it is still your input squared plus 8 times your input minus 24. So you'll notice we are still kind of inputting in the same exact way that we had done before. This is the piece that many of my students in the past have messed this piece up, okay? The reason they mess it up is because of the fact it's squared. Sometimes they just want to square the inner pieces. And because of the way we distribute and FOIL, you can't. So here's my little hint to avoid some of those stupid mistakes. Since it has a square on it, just write it twice. Oh, I'm sorry. Since it has a square on it, just write it twice. By writing it twice, you're more likely to see, oh, that's a FOIL. You know, that's a first, outer, inner, last. That's a distribute the 5C, distribute the 4. So then we won't mess up that algebra. Now, if you do the normal, good old distribution or FOIL, whatever you want to call it, you get 25C squared plus 20C plus 20C plus 16. So that's just 5C distributed, positive 4 distributed. It's just the distribution, but with two pieces. So some Algebra 1 teachers call it FOIL. FOIL only works if it's two terms and two terms binomials. So I just call it, I think of it as a distributed property. And then if there's 7 terms, you do the same thing each time. Now we have to distribute the 8. We get 40C plus 32 minus 24. Now once you have the big old list, just go in high power to low power descending order. So our highest power is 25C squared. There's only one of them. So it is what it is, what it is. You just leave it. Okay. Now as far as C's, we have quite a few. We have 20, 20, and 40. We have a total of 80 C's. I say 80, but I don't write 80. There we go. And then as far as numerical components, 16 plus 32 is 48, minus 24 is positive 24. Now, I don't expect you to do anything else. That is what it is. Oh, I'm sorry. Yeah, okay, that is what it is. So just leave it. You can write it grossly as an ordered pair. I mean, it is like 5c plus 4 is your x, 25c squared plus 80c plus 24 is your y, but that isn't very helpful when they're not actual numbers. So I would just leave it the way it is. Okay. Are there any questions about inputting into a function? Okay. Everybody got those ones down? Okay. So now let's talk about domain. Domain are the set of x's you are allowed to input. Okay, now I'm going to go kind of silly, but this will illustrate what I'm talking about. Let's go back to our oven. Inputs for our oven: cookie dough, chicken, vegetables. Could we put in there a can of aerosol? No, it'd blow up and kill our oven, okay? So it is not in the domain. So if it kills your device, your function, your rule, you cannot input it in there. So there's certain things we can't put in our oven because it will break our oven. So a function can only work with input that makes it work okay? So there's some ones I can give you some little hints to, okay? So if it's a polynomial, the domain is all real numbers. Remember that double-backed R we talked about in 1.1a? So you can say that double-backed R, or you can write all reals. If you're typing all reals, just use a capital R, like in bold, is common. So all reals. Why is that? Well, a polynomial, like x squared plus 2x plus 7, I can plug in positives, I can plug in negatives. Nothing messes it up, okay? But fractions, your input cannot make the denominator equal 0. Fractions, the denominator is not allowed to equal 0. So you have to look at the denominator and say, well, where can that equal 0? Those values are not legitimate inputs. It's going to mess up my oven. It's going to mess up my fraction. Okay? Then lastly, let's talk about square roots. Square roots, the inside value has to be greater than or equal to 0. The inside has to be greater than or equal to 0. So those are the main three things I'm going to focus on now. Now you can have a combo of things. You can have a fraction with a square root in it. So that poses its own unique issues. Or we can have a square root with a fraction inside of it, which causes its own unique issues. But if it's a polynomial, you don't have to worry about it. Any input is available. Just fractions of square roots get messed up, okay? So keeping that in mind, let's jump to example 5, where we find the domain, okay? Our first one here is a polynomial, okay? Our first one here is a polynomial. If you guys go into your Chromebook, and if mine loads, there we go, and if you type in f of x equals x squared plus 3, or remember that's the same as y equals x squared plus 3. This graph stretches from left to right without any holes or jumps forever, never, 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 okay? It is a continuous, what's called a continuous graph. The graph never ends, never breaks. you can start drawing it and you never have to lift your pencil ever and again. So if we look at that graph, because it stretches from left to right as far as we want, those arms of that quadratic are going to keep opening further and further and further. You can say that the domain is all real numbers. That's the quickest way to write the domain. Remember, we talked about interval notation in our last notes. You can also say that it's all x's from negative infinity to positive infinity are our input. So this notation is fine if they ask for it in words or they don't specify. If they say write it in interval notation, that's the one I want, negative infinity to positive infinity. Okay. Now let's take a look at the fraction. Now I said, you can still see it on the screen a little bit, that fractions denominators cannot equal 0. So the way that we are going to deal with this fraction is we are just going to set the denominator, 3x minus 6, equal to 0. And we're going to solve for x to find the exact value where it is equal to 0. Now, I would get in the habit of putting a slash through it to remind yourself, hey, that's not allowed to equal 0. And any of you that are typing, if you go to insert and then you find the little smiley face, one of the options is equations, and you can insert an equation. There is the not equal to options in there. Okay, so anyway, let's solve it. We're going to add 6 to both sides, which would give us 3x equals 6. Put a slash through. And then we divide by 3, both sides. 6 divided by 3 is 2. So x is not allowed to equal 2. Now, this means that our domain can be anything else but 2. So our domain, we would say that x is not allowed to equal 2. Now that would be if we just wanted to, write, we could even say x is not allowed to equal 2. Okay. But if we're doing it in interval notation, our graph is going to go to negative infinity. Once it gets to 2, it's going to jump across, and let me write this down here so you can see it better. It is going to jump across 2. There's going to be some hole gap, some kind of problem at 2, and then it gets to keep going. That is the formal way to write that. You can see here that we have skipped 2. This parenthesis means that I almost get to 2. So on the left side, I would get to 1.999. On the right side, I would get to 2.111. But 2 itself is not in the graph. Now, the way that you can check your work is if you go to Desmos, and if you type in the fraction 1 over or 1 divided by 3x minus 6, look at what happens at 2. Sorry. If you look at 2, there's no graph there. The graph comes super close on the left. That's your 1.99999. Super close to the right, 2.111. Or 2.0001, I think would probably be better. And then, but there's nothing at 2. But 4 works, and 7 works, and 10 works, and 2.1 works, and 1.9 works. But the others don't. Okay? So the graph and the algebra should always go together, or one of the two is wrong. Okay? So check your work on Desmos. It's not a bad idea to get used to that. And then our last one here is a square root. Now, what did I say about square roots? If you look up to the domain information, square roots, the inside has to be greater than or equal to 0. So if it's a square root like this one, now that doesn't apply to cube roots. It applies to square roots, and actually even index square roots, fourth roots. But square roots, you're just going to take the inside and set it greater than or equal to 0. That's all you got to do. And that's kind of what it says up here. The domain is where the inside is greater than or equal to 0. That will make the input work. It will not blow up our oven. Okay? So, solve that. What do we do to solve x minus 2 is greater than or equal to 0 for x? What's the only thing we got to do to solve it in one step? What do we got to do? How do we solve that? How could we? Yeah. Don't overthink it. You just add 2 to both sides. If we add 2 to both sides, we get that x is greater than or equal to 2. Now, how do we write that for the domain? Well, if we want to write it in an informal way, we see the domain is where x is greater than or equal to 2. Now, we learned interval notation so that we can start writing our domain as an actual interval. So we can say that the x's are from 2 to infinity. Remember, it follows that number line. Okay? So the bracket on the 2 is used if we have an equal to symbol. And then the infinity is just telling us we're going bigger and bigger and bigger to the right. So 3, 4, 5, 6, 7, 8, 9, 10.7, whatever is bigger than 2. Okay? So those are the 3 types that we need to focus on. Okay? Now, the last thing I want to talk about is a piecewise function. Now, the reason that piecewise functions appear in a pre-calc class or in like a college algebra class like this is, when you do a piecewise function, you want to think about it in a real life application. Well, okay, let's think about, especially cell phones a long time ago. Before unlimited plans happened, you might be charged nothing for the first 100 minutes. I don't know. And then for the next 100 minutes, you might be charged 5 cents a minute. And then anything after, the second 100, you might be charged 10 cents a minute. I don't know. But there was kind of like a structure where it was broken into pieces. Well, that happens a lot, actually, in real life more than you think. So I want to talk about this piecewise function so that you don't overthink it, because that's what I think most people do. Okay, so let's take a look. This function is called v of t, okay? And if I input a t such that t is some value between 0 and 15, so only the numbers between 0 and 15 use the top function. So if I plug in 1, it's just 4 times 1. If I plug in 7, it's 4 times 7. So anything between 0 and 15 uses the top. Now, anything between 15 and 240, but we don't include the 15 or the 240, but anything smack dab in the middle of 15 and 240, I get an answer of 60 no matter what. So if I plug in 20, I'm getting an answer of 60. If I plug in 100, I'm getting an answer of 60. That's called a constant function. Now, this piece, this bottom piece, I only use for values between 240 and 250, including 240 and 250. The borders match because the equal to. So if I plug in 240, I plug it into this one. If I plug in 245, if I plug in 247, 248, up to 250, okay? So a piecewise function just designates what piece based upon my input. So another silly little oven recipe or analogy. Let's say we have 3 ovens. The first one is used for cookies, but the second one is used for vegetables, and the third one is used for chicken. We can't put the input into the wrong oven or the oven doesn't work. Maybe they're set at different temperatures. I don't know, okay? So you got to think about it as make sure you're inputting into the correct piece of the function. But the 3 functions are acting independently, okay, in a way. Okay, so let's take a look at this first piece. We are inputting 5. Do we input 5 into the first oven, the second oven, or the third oven? The first piece, the second piece, or the last piece? The first one, right? Because it's between 0 and 15, we just do 4 times the input and get 20, and we're done. That's how that function works. I am inputting 5. 5 is only in this type of function. It's a value between 0 and 15. I only plug it in there, 4 times 5, but done. Okay. 15. 15 is a tricky one. It's on the border between functions. Which one has the equal to for 15? Does the top one have the equal to for 15? Or does the bottom one have the equal to, or middle one have the top has the equal to. This one has the equal to. That means we use the top function. So that would be 4 times 15, which is 60. Now let's say, I didn't put it, but let's go over to the side here. What if I'm plugging in 20? 20 is in this middle section. It's a value between 15 and 240. They did the math for you. When you input there, no matter what, you always get 60. So those pieces my students love to overthink. You get 60. They did the math for you. Don't overthink it. Okay? Where does our 245 go? Yeah, it's a value in here. So we're going to do negative 6 times 245, our input, plus 1,500. Let me do that. Negative 6 times 245 plus 1,500 is 30. Okay? So be careful when using piecewise functions. Do we have any questions about the homework you see here? Okay, so you just took those notes. I would take a picture or send them to me now.
Wait,
so that
have to unsubmit the last one and then?
No, it should let you resubmit. Try it if you, yeah. And I'm not taking any points off for you guys. I must not have remembered. We were slightly distracted by a dog on the picnic table, so. Anyway, the homework is underneath it. It pretty much follows kind of what we did. I just want to warn you, we do have a quiz coming up. We will be having a quiz, if everything flows right for the week, on Friday. I always review for the quizzes on Thursday, but it will, the day before. But I'm just warning you that is coming. So there you go. You have a little bit of time in class now to work on this, so use that time, and you can ask me questions. Everybody good with what you see here?